class, this video is going to help with 6-4. It's our last section in the simplex method. And this is like, what if it's not perfect and you have mixed problem constraints? So you're doing a maximize and we usually have, like lost my train of thought. Maximization usually has less than, but what if it had a greater than? Or what if a minimization had a less than? What if one of them had an equal? What if one had a negative where it shouldn't? What are we going to do? That's this one. Okay, that's this section. So I'm going to start, I'm going to have to do a little bit, stop the recording and make a part 2. I'm having a lot of issues with my recordings. So here's my first example. I am going to walk through a full example, then show different ways to do the constraints. So kind of teaching by example. What if I want to maximize P equals 2x1 plus x2, and it's subject to x1 plus x2 is less than or equal to 10, and negative x1 plus x2 is greater than or equal to 2. And then you have your positives. Okay, so if we look at this, what's wrong? Why is it in this section? Because when we have a max, it's usually less than. So this right here is a greater than. Okay, and so that's going to throw us off. So for the first equation, we've seen this one quite a bit, so this one's not that different. That first one for our slack variable will just be the x1 plus the x2 plus our s1 equals 10. So we've done that slack. We called it slack 1. We've done that a lot, so that's totally normal. Now this one is going to be different. We are going to now use what we call a surplus variable. And the surplus is extra from the left side exceeds the right sides when you change from one to the other. So basically it's really similar to a slack variable, but we call it something different, a surplus variable, because we have to add in what we call a big M. So it's a little bit different. So for should I write out minus? Okay. I'm just going to write out this part. So S2 is a surplus variable. Basically, it's going to become a negative S2, but because the left side will exceed the right side because it's greater. So the left side will exceed the right side. So I don't know if I have to write all of that out. Basically, do I need to write out the definition? Maybe. So for equation 2, it's going to become negative x1 plus x2, and it's going to become a negative s2 equals 2. So what became different? I can't write it as a positive. I have to write it as a negative s2. And if I include this s2, I'm going to have to add in, I should have left a little bit of a space. I'm going to have to add in what we call an artificial variable. Okay. The artificial variable, the whole point of an artificial is it has absolutely no meaning, but it allows us to use the simplex method with this negative s2. Basically, it's kind of like a placeholder. I don't want to call it a placeholder, but it is kind of like a placeholder. So what happens if something is the wrong way? I'm going to have to add in a negative slack variable and add in an artificial variable. Okay, so this method is called the big M, and here's why. Okay, so what we're going to do is to prevent the artificial variable from becoming part of our optimal solution to the original, we introduce this M. And the idea is this number is so big that we just call it M, the big M. Okay, so we add this M to our objective function. So it becomes P equals 2x1 plus our x2 minus MA1. Okay, artificial 1. If I would have had two artificials, like maybe I would have had another subject to, another constraint that was greater than, then we would have had another big M in our objective function. Woo! So now let's set up our tableau. We know this, we have all this now. Now we need to move these all over with your P. So it would become P minus the 2x1 minus x2 plus big M A1. So we move it all over. We've done that before. I haven't always showed that step. But here's your Simplex Tableau. I'm going to switch over to a new piece of paper just for a sec. Here is our Simplex Tableau. So we're going to start with, I'm going to definitely label these x1, and our x1s went 1, -1 from our two functions, and then a -2 for our objective function. Our x2s went 1, 1, -1. Our S1, and this is why I'm labeling carefully, because sometimes people put the A1 before the S1, and it doesn't really matter. You will get the correct answer, but you have to label to know which one is which. So our S1 only had a 1 right on our first row, and then the other two were 0. Okay, for S2, it was a little different. It was on the second one, but it was negative. Okay, artificial variable 1 only came in on the second one, and it was a positive 1. It was just artificial variable, no negative. And then you have your P, which was 0, 0, 1. And then we have our numbers, 10, 2, 0. Oh, I'm supposed to do that dotted because it's not a dual problem. Ah. Look, I could do this. Just erase a little here and there. Does that look dotted? I don't think it matters, but there you go. Looks dotted now. Okay, where are we going to start with this? We need to start by moving. Oh, shoot, I forgot the M in the artificial row. I was like, how am I supposed to move this? I apologize. Artificial has the M, which M was, it was MA1, right? So in the A1, we have the M. Like, how are we supposed to move the M? So our first thing, so our start, you need to move M. I was like, and we didn't write it on there. So our first goal is to move M. So we're going to take negative M times row 2 and then add it to row 3 and replace it on row 1. So we're going to basically multiply with M. So let me show you what I mean. We're going to take negative M and then times it by row 2, add it to row 3, and replace it on row 2. Okay, so now what will we have when we do this? We're only changing row 2. So when we do this, I don't have my cheat sheet. Negative m times negative 1 is going to be, so negative m times negative 1 is positive m. Positive m minus 2 is m minus 2. So this, I thought I was replacing on, did I push row 2? This should be replacing on row 3. Maybe I shouldn't record videos at 10 at night, but I've already tried this video 20 times and I keep getting my program keeps not working. So this becomes m minus 2. All right, that's so tricky. Okay, what did I do? Negative m times row 2, the artificial one, and then add it to row 3 and replace it on row 3. So next one will be negative m times 1, which is just negative m, minus 1. So negative m minus 1. Okay, then the next one, negative m times 0 is 0 plus 1 is 0, or plus 0 is 0. Negative 1 times negative m is positive m. Okay, so we do still have an m there. Next row is our artificial row, and that's negative m. That's going to become a 0. That's what we needed. We needed the artificial row to not have m. Okay, the last one was 0 times m is 0 plus 1 is 1. Okay, and then negative m times 2 is negative 2m plus 0 is negative 2m. All right, so did we change anything else? No. So we're going to write those in, negative 1, 1, 0, negative 1, 1, 0, 2, 1, 1, 1, 0, 0, 0, 10. All right, so now we're going to start our, we're going to just start our row operations. Okay, so we got our m moved out of our artificial row, and we could keep our x1, that's x2, s1, s2, a1, and p. Again, I like to just write them at the end because I don't like to write them on every single one. Okay, so the first one is looking at what is the most negative. Okay, so if we look at these, if we have a number and we minus 2, or if we take that same number and put a negative on it in minus 1, which one is going to be bigger? This one, or bigger in this, I mean more negative. It's going to be this one. Okay? So this one. A lot of them are like just m minus 2, m minus 3, so you're going to go with the m minus 3. All right? So this is going to be our pivot. So we go over here and we say 2 divided by 1 is 2, 10 divided by 1 is 10. So our pivot will be here. And luckily we're good because it's already a 1, so we don't have to make it a 1. So our first step here now is going to be, we want that to be a 0 and that to be a 0. So we're going to take negative 1 times row 2 plus this row. So let me write that. Okay, and then the next one, how am I going to get 0 here? Well, if this was an m plus 1, or in the middle, sorry, if this is an m plus 1, when we add them, that would make 0. So we're going to times by m plus 1, so we just change the signs. So m plus 1 times row 2 plus row 3, replacing on row 3. And we're never changing our row that is our pivot. So pivot row stays the same. -1 times row 1 plus this is -2. Wait, negative, where did I get +2 on my notes? I might have made a mistake. So -1 times, nope, I'm right. -1 times a negative is a positive plus 1, so that's a 2. I went the wrong way. Negative times row 2 plus this one is a 0. Negative times a 0 is a 0 plus 1 is a 1. Negative times a negative is a +1 plus 0 is a 1. Negative times that is a -1 plus 0 is another -1. 0 times anything is 0 plus 0 is 0. -2 plus 10 is going to give me 8. Perfect. One pivot almost done. Now we have to do our m's. M plus 1 times -1 is going to give me -m. I'm just going to write it maybe over here for you. So think of it as -1 times m plus 1 plus m minus 2 to add it to this. Okay, so what happens here is you're going to have -m plus, or minus 1, excuse me, plus m minus 2. What happens to your m's? They actually cancel each other. So this was just like our little side note, and we have -3. Yay! See you later, m. Okay, next one. M plus 1 times 1 is m plus 1. Plus that would make 0. 0 times anything is 0. Or no, yeah, here. 0 times anything is 0 plus the 1 is plus 0 is 0. -m plus 1. Can you visualize the m's will cancel on this one and you're left with -1? Okay, m plus 1 times 1 is itself plus 0. So now I have an m plus 1 here. 0 times m plus 1 is 0, plus 1 is 1. And then 2 times m plus 1 is 2m plus 2. So it just becomes a 2. Okay? Totally weird, I know. All right. So then we're here. Do we have any more negative indicators in the denominator? Yeah, we have the -3. Okay, so -3 here. So then we take a negative, we can't use that pivot. So we can only use this pivot. So we don't have to divide. We can't use a negative pivot or a 0. So we're going to use this. So our first step would be divide by 2. So row 1 divided by 2. That's going to become 1, 0, 1/2, 1/2, -1/2, 0, 4. Okay, then the other rows stay the same for this one. And our pivot was here. Okay, so now what are we going to do from here? We're going to make that a 0 and that a 0, and we should be, I hope we're done after this pivot. We'll see. I think we might, I should know the notes in front of me, huh? Okay, so from here, we would like a negative times row 1, right? Oh no, we don't want it to be negative. We just want row 1 plus row 2 and replace it on row 2 so that they become the 0 right here. And then if this one's a 3, then this, we could add it to the bottom and get a 0 there. So 3 times row 1 plus row 3 would replace on row 3 would get us a 0 there. So let's take a second and do that. See if I can move that up just far enough. Like that. Okay. So just adding these 2 rows, and that's going to replace on row 2. So row 1 is going to stay the same. And then this one becomes 0, 1, 1/2. I'm just adding them. 0, 1, 1/2. -1 and 1/2 make -1/2. 1 and another -1/2. 0, 4, 5, 6. Okay? All right. Bottom row. To get this 0, we needed 3 times the top. So 3 times 1 plus -3 is 0. 3 times 0 plus 0 is 0. 3 times 1/2 is 3/2 plus 0 is 3/2. But it's positive. Yay! 3 times 1/2 is 3/2 minus 1. How did I get? Oh, now 3/2. Now I can't think that through in my head for some reason. It's going to be 1/2, right? So let me just check. So 3/2 minus 1. Yeah, I don't know why I had to double check. 1/2. Okay, and then 3 times -1/2 is -3/2. Where am I? -3/2 plus the m plus 1. So the m stays the same because you can't add a number and an m, but I have 3 times -1 is -3/2 plus 1 on there, so that'll give me -1/2. Okay, and then 0 to this is just going to stay at 1, and then 4 times 3 is 12 plus 2 is 14. Woo! We are done. M is a huge number. So a huge number minus 1/2 is going to be positive. So we do have one negative down here, but this one will not affect us. So let's take a second on our final tableau and let's label what we had. X1, X2, S1, S2, A1, P. So what's our final solution? Well, our max will be P equals 14, right? X1 is going to equal 4. It's not a dual problem. We're not looking at the end. We're saying it's going to equal 4. Only on the dual problems is it the weird solution. X2 will be 6. Okay. S1 doesn't make sense, so it equals 0. S2 doesn't make sense, so it equals 0. A1 was artificial, so it equals 0 as well. Better be. Okay, it was a fake thing in there from the beginning. So that is how we use big M. Okay, so I'm going to have to give other examples because this is 25 minutes here in a different video. But I want to remind you here real quick is that you can actually skip the dual problem and use this method as well for a minimization. Just a side note, you can. It's a little bit harder, I think, but you can use this. Okay, so, well, maybe I'm going to try to show you one other thing before I make the second video. I just worry because every time I've made a long video lately, which has been all of the Simplex, my computer doesn't actually save it right. Okay, so let's say I'm not solving this. So let's say we want to maximize and we have P equals 2x1 plus 5x2 plus 3x3, and it's subject to x plus 1 plus 2x2 minus x3 is less than or equal to 7. It's a max. Can you have less than? Yeah, it's a standard constraint. We're okay. But what if I then have negative x1 plus x2 minus 2x3 is less than or equal to negative 5? Is that constraint okay? No, I can't have the negative 5 on the other side. Okay, so we'll have to fix that one. So next one, what if we have x1 plus 4x2 plus 3x3 is greater than or equal to 1. What is wrong with this one? It's a greater. So this is really similar to what we just did. We needed it to be less than. Okay, and it was greater. So we'll have to fix that with an artificial and an m. Okay, so then let's see, so a, b, c, I got 3. So what if we have 2x1 minus x2 plus 4x3 equals 6? I can have an equal. I can only give this many hours or something. You could have an equal. That is something that is different, and we're going to have to show that one as well. So give me a sec on that one. Oh, I think that's all A, B, C, D. Yeah. So this is A, this is B, this is C, this is D. This shows all of our different constraints that we could have to write. So we know this first one doesn't need anything special. So if we went to write A out, it would be x1. We're going to write it as a slack variables. It would be plus 2x2 minus x3 plus s1. Okay, equals 7, wherever we would, how we have that space, but equals 7. Done. Nothing real special for that one. Okay, for B, what was wrong with B? We can't have that negative on the other side. So I am going to times by a -1, but I'm going to have to add a negative surplus. So let's write what I'm going to have to do. Multiply by -1 on both sides, and add a negative S2. So let's take that and do that, okay? So multiply everything by a negative, and when I do that, what's it do to the symbol? It changes it the other direction. Okay, that's it. I kind of feel like you could times it by a negative and then it would look like this one. It's true. So it becomes x1 minus x2 plus 2x3 is greater than or equal to 5. Okay, so that's what it becomes if I times by negative. So then let's write it with its slack. It will become x1 minus x2 plus 2x3 space, or however you want to think of that, and a negative s2, okay, plus an a1. Negative s2 plus the artificial, equals 5. So I just put it as a negative, and we have our artificial. Artificial because it was the wrong way. Okay, so basically when we times it, it became the other way. C is one similar to what we've already done before. It's going to become x1 plus 4x2 plus 3x3 is now, we are on our third one, so it would be a negative s to the third plus our second artificial variable equals 1. So we had to do our negative s again, and then we had to do our second artificial variable. The last one, it has equal. So what we're going to do is just add in an artificial. We don't need surplus. Why don't we need surplus? Because we do surplus because they're greater or less than. We don't have surplus when it's already equal, but we do need an artificial variable when it's equal. So it'll look like this. What were our numbers on that one? 2x1 minus x2 plus 4x3, and then it's going to be plus the a3 equals the 6. Oops, I just said that and you couldn't see it. Give you a sec to look through that one. All right, so what will our objective function, so our new objective function? I am no way in heck am I solving this. I don't even know if I could have enough paper with me. We just wanted to look at the different ways that these constraints could go to. So if you have a negative, you times by a negative, and then you end up with a negative artificial A. If it's going the wrong way, you have a negative artificial and an A. Okay, so new objective will be P equals 2x1. Oops. 2x1 plus 5x2 plus 3x3 minus MA1 minus MA2 and minus MA3. And then that's how we write it, right? And then we minus them all to the other side to write it as our bottom row in our tableau, because in our tableau the m's all become positive. I'm not going to have a bunch of m's like this, honest, I promise. All right. We'll see if this video works.